My dear friends, hello, my dear viewers, YouTube viewers. This is Mujahid, and welcome to my new YouTube channel, MJ Makes Easy. So, here I am to discuss with you the topics of maths, physics, and also chemistry. So, first, I have chosen to start physics topic for you, and the topic is kinematics. The topic is kinematics. This kinematics is a branch of classical mechanics where we learn the motion of a body, whether it is at rest or is it in equilibrium. Right? So let me define you first the definition of classical mechanics. Mechanics. So it is the oldest branch of physics. Oldest branch of physics which explains the state of body, whether it is in rest, motion, or equilibrium. What it is? Mechanics is the oldest branch of science, physics, which explains the state of body, whether the body is in rest or motion or in equilibrium. Rest. What is rest? Let me explain rest and equilibrium in comparison. Let me explain you about what is motion. What is motion? So it is the change in the position of a body. What it is? It is the change of position of a body. That is defined as what? Motion. Now let's discuss about rest and equilibrium. What is rest? Where the body is not moving. Is it okay? Is it okay? So let me correct it. Let me make it more perfect. Where the body is not moving with the time. With the time. Whereas equilibrium. What is equilibrium? Equilibrium may be, so let me explain in small two terms. That is, rest can be equilibrium, but equilibrium may not be rest, because the body can possess equilibrium when the bodies are in motion also, when the bodies are moving with constant velocities. Then hence if the bodies are said to be in equilibrium, it doesn't mean that they are at rest. So here obviously this rest, it means what? Equilibrium point where net force is zero. What is that? Net forces are zero. So rest is can be termed as equilibrium, but here when the bodies are at rest, here the net forces will be zero. It means the body is not moving with the time. But whenever we come to this equilibrium, the bodies may be in motion. Maybe in motion, or let me explain a small example. A block of mass placed on a table, a mass m. So from here also the force F is acting, from here the force F is acting. Both are acting in opposite direction. Will the block move? No, the block doesn't move. Even the forces are acting, the block doesn't move. Now this can be termed as what? Equilibrium. What is termed as what? Equilibrium. And this topic will explain us how the body behaves when the body is in motion, when the body is moving. Right. So I'll discuss with you remaining topics. First copy, pause and copy. Then let me continue with the other topics. Right. The mechanics. Mechanics into two. What are those? They are statics and dynamics. What are those? Statics and dynamics. This statics explains what? What explain? The name itself says that statics. It means the body is under rest. The study, what is this? The study of body when it is at rest. When it comes to dynamics, it is divided into two parts, that is kinetics and kinematics. Kinetics and what? Kinematics. Here, this kinetics deals with the study of a body when moving. When what? Study of body when it is moving or when it is in motion. Here we check the cause of motion. What we check? We check cause of motion. We question that how the body is moving, why the body is moving. But when we come to kinematics, here it is also the study of motion of a body, but ignoring what we do, ignoring the cause of forces. We don't ask the question that why the body is moving. Just a body is moving with this much velocity. Yes, the body is moving this much velocity. We don't ask the cause of motion. We don't ask the cause of force. So that is our topics. That is, what is that? Kinematics. What is that? Kinematics. It is study of motion of a body when there is no cause of forces. We don't question the cause of forces. Hope you have understood. Let me continue. Kinematics. The body, any body moving, a car is moving, a body is moving, a man is moving, right? When he is moving from one point to the other point, it may be along a straight line. It may be along a straight line. It may be along a curve. Right? It may be along some axis. So, in this kinematics, we can discuss about the motion of a body. What is that? The motion of body in one dimension, in two dimensions, and also in three dimensions. What are those? In one dimension, in two dimensions, and in three dimensions. Right, ma? So now, one dimension. Here, we can call this one dimension, a motion of body in one direction is nothing but a straight line. What is this? Straight line. This will be in x and y axis. This will be in x, y and z axis. Right. So you can copy this, pause and copy this. So let me discuss you about motion in one dimension, motion in two dimensions, motion in three dimensions. It's the first YouTube video. Right. So now, motion of a body, what is this? Motion of a body along a straight line, or I can say rectilinear motion. What I can say? Rectilinear motion. What I can say? Rectilinear motion or straight line. That is 1D. Then it may be in 2D, that in x and y axis. It may be in 3D, that may be x, y and also z axis. X, y and also what? Z axis. So now we will discuss deeply about this motion of a body along a straight line or motion in one dimension. Right. Okay, you can copy this. So when you have traveled, so you might have experienced some force. You might experience some moving. You experience something is pulling you, pushing you. I hope you all have experienced this. So yes, so let's have an example, a deep example regarding the daily routine, what we do in our daily life. Every day you start from your home to the school. Maybe on foot, maybe on your bike, or maybe in a school bus. Right. So if you're starting from rest, then you gather some speed and you start moving from one point to the other point, to travel from one point to the other point. Obviously, you're taking time. When you take time to move from one point to other point, you are covering some distance. Then the body has got some velocity, some speed. So that we should discuss here in this kinematics chapter, which are basics, and should be known by every student. So let me discuss this topic. What are the first topics is what? Distance. What is it? First is what? Distance, and second is displacement, and third is speed, fourth is velocity, and fifth is acceleration, and sixth is jerk. What it is? A jerk, a small push, a jerk. Right. So distance. Again we can come across here uniform, non-uniform, some types of speeds. Here also the same, uniform and then non-uniform. Yes, I know. Then you come across initial velocity and then final velocity. Initial and final velocity. So let us discuss these all topics one by one. So let me explain you first about what is distance and what is displacement. Would you like to know? Yes, then listen. Let me first about what is distance. What is distance and what is displacement? Distance and displacement. Right. So distance. Let me give a small short story for you. Right. Alright. Then let us enter into our physics topic. Let's go generally. Let's understand generally what is distance and what is displacement. Are you ready? Yes. So imagine that you are starting from home. You have got a special class on Sundays. Then you have started from your home to the school. You have taken your father's bike, your dream bike. So what do you do? What do you do? Your father, what do you do? Your parents say that yes, beta, you just directly grow from home to school and from school to home you return back. But what do people do? You are so naughty. So what do you do? You travel from here to your friend's home. Then from friend's home you go to some bakery. You shop somewhere and you go in some all lanes and finally you come to school. And then even after the class also you move at different places and move to your home once again. Right? So your father talks about the displacement, but you have covered the distance. Hope you have understood.